Ako ay may lobo, lumipad sa langit, di ko na nakita. Oh, class, what did you do when I gave you a deflated balloon? Wow, what a divergent mind. You blew it by the use of your mouth, right? Correct. Air is blown into the balloon. Does air have significant effect on the balloon? Yes, you got it right. The pressure of the air pushes the rubber, making balloon expand. If that's so, can you now define what pressure is? Exactly. Pressure of a gas is the force exerted by the gas to an area or space. If a balloon was inflated, it expands because of the molecules of gas strike in the wall of the balloon, causing a pressure on it. Again, class, what is the definition of the pressure of gas? Do you have any idea of what international standard unit or the SI unit being used for pressure? Wow! You just blew me away! The international standard unit used for pressure is Pascal or PA, and it is named after scientist Blaise Pascal. Did you know, class, that the unit Pascal is equivalent to a force of 1 Newton acting on 1 square meter? Pressure is equal to force divided by area, or if we derive it, its pressure is equal to the product of mass and acceleration divided by an area. When I asked you to fill again the balloon with air, what happened to its size? What a genius mind! Adding air inside the balloon is making the volume occupied. Can you now define what volume is? Great! Volume is the amount of space that a substance or object occupies, or that is enclosed within a container. Take note, class, the word space. Molecules of gas occupy space. It was proven when a gas fills up its container. Did you understand? If that's so, what happened to air as you start squeezing the end of the balloon? You're really a great observer. It became too rigid because of the volume of the balloon filled up with gas. So, the standard unit used in volume? Correct. The standard unit for volume is liters. You will encounter most of these units as we go along. In this lesson, we will be dealing on the 3 properties of gas: the volume, the temperature, and the pressure. If one of these variables change, there is a corresponding change in other variables depending on its relationship. Always remember, class, that in Boyle's law, the temperature is always constant. It is not changing. Is there any question? Now, you are able to distinguish the difference between volume and pressure. I am pretty sure that you can now explain how changes in pressure affects the volume of the given situation, or vice versa. Take note, class, that gases inside the balloon can be compressed into smaller volumes. But what happens to a pressure when the volume changes? Can you explain how the volume affects the pressure of gas held at a constant temperature? As the pressure applied, the same number of gas molecules are squeezed into smaller volumes. Yes, I know you are thinking. This is indicated in the third law of motion of Isaac Newton. It states that when two objects interact, they exert equal and opposite forces on each other. When gas molecules collide with the wall, both the wall and the particle experience the force of the impact. Okay, let's have a short history about Boyle's law and who is the proponent of this law. So, the relationship between volume and pressure of gas at constant temperature was first stated by Anglo-Irish physicist Robert Boyle during 16th century. He performed an experiment wherein he dropped a fixed amount of air in J tube. He changed the pressure and controlled the temperature, and then he observed that the effect of the volume of the air inside the J tube is inversely proportional to the volume of the J tube. Now, think of it. If one variable increase and the other one decrease, what do you think is their proportional relationship? In mathematics, the two varying quantities are said to be in a relation of proportionality if it is connected to the constant and proportional relationship. So, we have two kinds of relationship, the direct relationship and the inverse relationship. What are their differences? In direct relationship, if an increase in one quantity leads to the corresponding increase in other. This has the mathematical formula of y is equal to kx, where k is the constant. Like for example, in mathematics, the circle. Circumference is equal to pi times the diameter, which is a direct relationship with the pi as a constant. A bigger diameter means a bigger circumference. Do you understand the direct relationship? Now, let's go to inverse relationship. When we say inverse, if one variable increase, it leads to the corresponding decrease in other. Mathematically speaking, this is expressed as y is equal to k divided by x. Like for example in science, for a journey, travel time is equal to, yes, distance divided by speed, which is an inverse relationship with the distance traveled as a constant. The faster the travel means a shorter journey time. Do you have any question with the two relationship? If none, let's proceed to the next concept. Now, take a look at the equation of Boyle's law. If you're going to relate it in your math lesson, what kind of algebraic expression is the equation of Boyle's law? Correct. That is a commutative property of multiplication. The V1 times P1 is equal to V2 times P2 is an example of algebraic properties of equality.